Okay, there we have E as well. Oh, sorry, B. Are we all fine with B?
I don't
Oh, honestly, I'm not gonna say.
I got no, I got one.
Mine. I got one of a five.
I got one and a five.
Five.
Yeah. Thank you, Simon, for your voice support, but I doubt. Oh my God, already.
Maybe you did 3 and 2.
I can speak when so quick.
It added that.
Then I just one.
Okay, I'll find it. I'm gonna complete.
Surely we can't do that.
Okay, yes. Okay, I'm fine with E.
Wait.
Yeah, so you multiply these two and then you minus that from the two.
Yeah.
So that's 81 and that's 8.
Yeah, Friday
I guess. Fine, Friday Josh will have to just sit up to maybe Monday, McConnell doesn't know half the time. Okay, so any problems there with equal G? I got 1 of 7.
I got one of the negative 4.
That's
I got one of the 7. Right.
Alright.
Yeah.
Okay, negative 5. Then just focus you do negative 6 minus negative 2, which is plus 2. Right? So that's how you get to negative 4. So you can write 1 over negative 4 if you want to, but it's just simple as the minuses in front of that fraction. And then you swap your elements of your leading diagonal, so that 3 goes over there, the negative 2 goes to the top there, and these two stay in the same position, but they change their sign. Okay, next one, we do 12 minus 10, which is 2, yes? You swap those two and you change those two signs, okay? For H, 4 times negative 5 is negative 20 minus negative 2. So negative 20 plus 2 is negative 18. You swap those two and you change those two signs. Okay, I was the last one of number 2. So that product is 17, positive 17 minus 10. Right? Which is 7.
Please.
Yeah, I would say it was down to number 3, which is not good. It is. Okay, so I'm right. You don't have math. So she will finish teaching you everything that's left on Wednesday.
Everything.
That's just like that's all we're gonna do. Yeah. I think we did do 1 or 2 exercises. It's basically just that. The textbook is quite thin, but they are supposed to post a practice test today. A week before. I'll just have to find out if the person taking that text remembers, but I'll find. Are we finding these ones? I'm scared to mark number 5, hey? Given how number 2 went. I was scared. Yeah, we can.
What was number 5?
5 was similar stuff, but there was a long way. Oh, okay. Inverse of A, inverse of B.
Got one of the 22.
Okay, so that is negative 10, right? Minus negative 12. So negative 10 plus 12. So 2. Right? Then you swap those two and you change the signs of them. All fine with A. I'm not saying anything, I'm not sure what that means. I think A is correct. No, it is correct. I'm looking to see. I'm very confused. Okay, well, we'll look at it now. All right, for B, the inverse of B, let's just go through that together. That is 10 minus 12, so negative 2 now, right? Then you swap those two and you change those signs. Okay, for C, they're now saying A plus the inverse of A. Now, guys, when you want to add these together, you do have to multiply that half into the bracket, unfortunately. You do have to multiply the half into this bracket because remember, when you're adding matrices together, you add the same elements in the different matrices. All right, so let's just check if that's correct. A half times -2, do we agree, is -1? Then a half times 4 is 2. A half times -3 is -3/2. And hang on, and a half times 5 is 5/2. Okay, then you were supposed to add all of these. So let's just check. 5 minus 1 is 4. -4 plus 2 is -2. 3 minus 1.5 is 1.5, okay? 3/2. And -2 plus 2.5. Oh, yes, I went wrong there. Okay. -2 plus 2.5 is supposed to be a half. Not 9/2. So that is a half. So that means that this one must also just change. I have a question. Why is the second A bracket have the different numbers? No, I know that. This is A and this is the inverse of A. This notation means inverse. Yeah, I know. So what I did here, so in order to add them together, you need to have, you can't have a number in front of it. You have to multiply that number. Yeah, I know, but the A there is 5, and then -4 and 3 and -2, different numbers completely. But they're the same letter. This is A, and this is the inverse of A. It's not the same. So this notation, whenever you see that -1, that means the inverse. I know.
That's why you get.
U and A. But it's A and A over 1. Oh, I see. Okay. No. It's the inverse. Yes.
If we, it doesn't like fraction, that's.
No, it's fine. Okay, B. Yes, Jonathan, why would it not be fun?
Yeah.
Stop talking about physics in my class, please. No, that's not my problem. Okay, B minus the inverse of B. Okay, so here inverse of B, we said this is correct. So -5/2, +2, +3/2, and -1. We're fine with this part. And now we're supposed to subtract, guys. So again, hopefully I did this correctly. 2 minus -5/2. So this is actually 2 plus 5/2. Right, which is 9/2, yes. 4 minus 2, which is 2. 3 minus, again, 1.5 is 1.5, 3/2. And 5 minus -1 is 6. I didn't write my other option, guys. Just the second option, by the way. I think I did say the other day you don't have to take the number out again. But sometimes they put an instruction there saying that all the elements of the matrix have to be whole numbers. So then you would have to take it off. Okay, so here I didn't actually say anything about it, but in order to get rid of those halves, essentially, you have to, it's almost like you're taking a half out as a common factor, in a sense, from each element. So you have to say, okay, what's 4 divided by a half? 8. Right? And does it work the other way around? Guys, a half times 8 is 4. Right? So you can check it like that. What's -2 divided by a half? -4. 3/2 divided by a half is just 3, and then a half divided by a half will just give you 1. Okay. So let's quickly do the next one together. If we want to write this with all whole numbers, what number must I write in front of my matrix? A half, okay? Because both of those are over 2. Okay, so that means that that is just going to become 9. 2 divided by a half is 4. 3/2 divided by a half will give you 3. And 6 divided by a half will give you 12. If you're struggling with that division idea, you can just check if you're going backwards, are you going to end up with this? So if we were to actually multiply this half by each of those terms. So half times 9 is 9 over 2. A half times 4 is 2. Okay, you can take it like that. Alright, but guys, if it doesn't say anything like that in the instruction, you're more than welcome to leave it like that. You'll get full marks. Okay, let's look at E. So now this was the two inverses. I hope I found the keyword. And if not, I have to walk around. Alright. Wait, how old is this? 203. But they're very close to the dad work from home, so he takes her. No, don't put your child on walk alone. No, definitely not alone. Yeah, unless it's a very resourceful. Answer was, okay, let me just put this on. You go. I mean, it's the size of the screen. Yeah, but something wrong with my safety. But yes, you can save it.
No, not granted to make photos on my iPad only.
Okay, guys, the inverse of A plus the inverse of B, any issues there? Someone saying yes, so I'm going to assume the answer is no.
No, I'm just,
You're just vibing, huh?
yeah,
Okay.
I'm just laughing at my stupidity.
Alright. Okay, I'm just writing the other option for you. Like that. Oh, yes, that's what will happen. So if I was on marking that, I would have to see a. Fun for me. Okay, AB, the product there. Are we fine with that product? Remember, let's go through this again, guys. Matrix multiplication is not complicated, it's just very easy to get confused. So for your first row, first column element, you do first row, first column. Okay, so you're going to say 5 times 2 is 10. And negative 4 times 3 is negative 12. 10 plus negative 12 is negative 2.
I think it's very different.
Oh, did I? Please don't tell me I wrote 8 on wrong. Why do I feel like that?
It's negative 2.
Oh,
I think it's negative 2.
Oh, it is negative.
okay, you know what, guys? It's fine. Okay. The first two values should be fine. Negative 2 and 0. Yeah?
Yes.
These two are correct. So the next two will be wrong because I worked with a positive 2 instead of negative 2. So let's do them together. It's fine. It's a good learning experience. No.
Oh, yeah.
Okay, so let's do this one, guys. Second row, first column is going to give us that element in the second row and the first column. Okay, so we're going to say 3 times 2 is 6. And then negative 2 times 3 is negative 6. Right? 6 plus negative 6 is 0. Okay, last one. 3 times 4 is 12. And negative 2 times 5 is negative 10. What is 12 plus negative 10? 2. Here we go.
I don't think that's not the
Now the next one is also going to be wrong here, guys.
I can't, man. Does that have anything to do with identity?
No, if it was a negative 2 and a negative 2, then you could take negative 2 off and you would have that. But these are different. See, if they had to be,
If you had if it was negative,
then you would write it in front. So you would do what we did here. You would divide each term by that number. Okay, guys, what is this inverse? Let's do it together quickly again because mine was wrong. So you're going to do for your determinant, negative 2 times 2 is negative 4, right? Minus 0. So we're going to have negative 1 over 4 there.
the only person that actually multiply without, I would offer in front of the. They're asking, well, why is multiply?
I'm not multiplying anything else. I'm still doing English. Okay, then I need to remember I'm not wearing a I literally got told off by a teacher the other day. The teacher was like, you know, I couldn't see your facial expressions before. Now I can. Okay, guys, please tell me that anyone get that for 8. And you can say yes. Thank you. Oh, no.
Good.
Christina, did you say? Oh, okay.
One of the last many.
Okay.
Well,
Sorry, Jonathan. Majority rules. Let's go.
it feels like
I want to start with an 8. It sounds like it started the brain. All right, write that down quickly, please, while I do absentees.
no, mate.
So you say, when you get to the
Okay. Right on the steam part. There's so many blank pages left. Like, why is there any hours? Where is my black pen?
Mine.
Now people are definitely missing this. And I feel like it's Daniel or Jonah.
I don't see the rate. That's all.
I don't know how bad thing. That's our first team. State now. Third team. We better win. Because my friend and I are going to watch, and the one friend goes to the school. I'm like, yeah, that is terrible. Is Thomas here? No. Yeah. He's not around. Who is that? I don't know.
Grade 11.
Were they? I didn't know about that. Yeah. Oh yeah, covering extended Friday. Okay. I don't think any grade 11. The thing is, they have to come, otherwise they're not allowed to. It's like if you're absent on a Friday, you can't play in a match on Saturday. Like that's against the rules. Oh, really? So what they're gonna do, the sneaky buggers, they're gonna come in late. Which is what they did yesterday. They're gonna come in late. They're gonna come in like the last hour of the day. And then they're like, oh, we were at school. Which is why I had 4 kids in my grade 11 class yesterday morning at 8. Salma is here. Oh, it is a small class. Yes, we did. We drew exponential graphs. Okay, guys, matrix equations. Do you have a those things? Okay. Thank you, thank you. All right, matrix equations, guys. This is now the last section of matrices for grade 10. It's the last thing that we're going to do. We are going to just practice. I'm thinking actually on Monday we should maybe rather do 4 because the test coming up. Yes, yes. Okay, so we will, we'll pick up on this stuff again a bit later, the following week probably. Now, guys, matrix equations is basically a way of solving equations with multiple variables. Now, in 4 we did simultaneous equations, right? Where we solved for 2 variables in 2 equations, which I think was quite doable. Then in AP, when we did partial fractions, we sometimes had 3 variables in 3 equations, right? Which was a little bit more complicated. If you are working with matrices, matrix equations, you can use these to solve 5 equations with 5 variables. We're not going to do that, but that's why I'm teaching you how to do it. Okay. So it's going to seem a bit silly to use this method to solve two variables in two equations because I think just the algebraic method would be shorter, okay? But we do have to learn this in grade 10 so that we can use it for bigger matrices going forward, okay? So, what we are going to do is, let me just write this example. I think we're going to jump straight into an example and then we'll write like steps on the side.
I really like selling us on this.
Is there a math inside?
No,
As big as
in
the
grade
page.
10, we don't go further than
That was so good.
like inverses of 2 by 2. But in general, no, you can make matrices. He's just joking.
That's good.
Yeah.
No, it's been the first time in a while.
Actually, no, you never sleep.
Good for you.
You always have I got 2 hours sleep.
Nah. I never get
Yeah, 4. I sleep well, but like 2 of the morning wake up.
All right, are you writing down what I'm writing down?
Go over here.
Okay, set up a matrix equation, sorry, I don't know why I said that so strangely. So guys, the matrix equation is always going to have the same form, all right? So it's going to be in the form AX equal to B. And we're going to translate our two equations into a matrix equation. All right. So what we're going to do is A is going to be the coefficients of the variables. I'll show you now why we do it like that. The second matrix, X, is going to be a matrix of the variables. And then B is going to be a matrix of the answers, right? The constant terms. So guys, for your A matrix, your first matrix that you're going to write down, what you're going to do is you're going to put the coefficients of the same variable next to each other. So we're going to put the two coefficients of the x term in the first row. Okay. So you're going to take, what is the coefficient of x in my first equation? 8. And the coefficient of x in my second equation is -5. Oh dear, I'm saying the wrong thing. Sorry, it's going to be the other one. They're going to be in a column. Sorry, in a column. I said row, I meant column. Sorry, my bad. So these two, I'll highlight them so that you can see that. Sorry. So the coefficients of the same variables are going to go underneath each other. Okay, so we're going to say, we'll just line this up, 8 and -5. So let's highlight them. There we go. There's that 8 and there is that -5.
Two x variables. What is the math? Yes.
Okay, then we're going to put the coefficients of y in both equations again underneath each other. So we're going to see now, I'll show you why we do that. So the coefficient of y in the first equation is 5, in the second equation, negative 2. So we do 5 and then negative 3. So does that make sense? The same equation is next to each other. That's actually what I was thinking when I was speaking about next to each other earlier. So 8x and 5y, you put 8 and 5 next to each other, right? And negative 5x and negative 3y, you put negative 5 and negative 3 next to each other. Okay, so you're almost reading in one equation like that, in a line. Okay, that is your first matrix, guys. So we're going to put our brackets around that. Second matrix is going to be a matrix of the two variables. Now you are going to put these two variables underneath each other. Again, I'll show you now why that is. Actually, if we put them next to each other, would we be able to multiply these two matrices together? If I wrote it like this, don't copy this down. I'm just going to show you quickly. Don't copy this, don't copy this. If I did x, y, would I be able to multiply these two matrices together? This is a 2 by 2. This is a 1 by 2. So, right? Remember, if we have 2 by 2 and 1 by 2, because those two numbers are not the same, we couldn't multiply them together. Okay. So, yes, the ones that I underlined. Oh, did I? Oh, no. I'm sorry, guys. I really hope I'm not confusing.
It's a bit like a term.
It's fun,
We forgive you.
yeah. Okay, and that is then equal to, so that's A, the A matrix, the coefficients of the variables, the X matrix, which is the matrix of the two variables, which before you see. And then we're going to put the constant terms next to that. Now, guys, just repeat. Feel that the root, but
We're just so tired. We're staring.
clearly I can relate. Okay, now guys, if we're looking there at this equation that we're taking up, a 2 by 2 and a 2 by 1. Let me just highlight the correct one. Those two inner numbers are the same, so I can multiply the shield. What is my answer going to be, guys? If I multiply those two matrices together, it's going to be a 2 by 1. So two rows, one column. So it's going to look like this one, right? So that is what we're going to write for our constant terms matrix. Negative 1 and positive 1. It's going to be a 2 by 1 matrix. Now, how do you know which one was the earlier one?
Well, actually, don't do that. To be always
Always the numbers of the first. It depends on if you want to write this equation values first. No.
Okay, so then you don't have to
But
match.
you can't mix and match.
Then
You can't. So if you do 8 and 5, then you have to do negative 1. Okay. Alright, guys, let's just quickly look at this. The reason why I've set my matrix equation up like this, and by the way, that would be your first mark. You get 1 mark for doing that, for setting up your matrix equation. The reason why I've done that is because if I actually multiply these two matrices together, I will get these as answers. Let's just quickly do this matrix multiplication, just maybe next to it, because this is not actually a part of when you're solving this equation. I just want to show you guys how it works. You'll say first row times first column is supposed to give you that value, right? So first row times first column, 8 times x is 8x. Right? Then you're supposed to add 5 times y, which is 5y. And that will then equal negative 1. And do you see that that is my first equation that they asked us to solve? Okay? If you do the next second row, first column, that is supposed to give you the value in the second row and first column of the answer. So let's see if that works. Negative 5 times x is negative 5x. Then you're supposed to add negative 3 times y, so minus 3y, and that should then equal 1, which was our second equation. Okay. So guys, if you've set up your matrix equation and you're actually not sure whether you've done it correctly, quickly do the multiplication and see if it does give you the two equations that you started with. Okay. Now the next thing that we are going to do, so step 2.
Only works now, as, same number of equations as you
Yes.
to get quadratic, you have to have quadratic.
Multiply both sides by, let me actually not write it like that. Multiply both sides by a to the -1, which means what? The inverse of it. So now we're going to start using the inverse method. Basically, yes. Yeah. Guys, do you remember what we wrote down on Monday? You might not. So we might have to just go back to that note. I'm just going back to the note. What did we say here? The inverse of a 2 by 2 matrix, we said two matrices of which the product is the identity matrix are inverses of each other. So basically, if you take a matrix and you multiply it by its inverse, you will get the identity matrix. Now, what we didn't write down about the identity matrix, can you just go back to this in your notes quickly? The identity matrix is called the identity matrix because it is a multiplicative identity, which again, you might not know what that is. I'll tell you now. We spoke about multiplicative inverse. But the term multiplicative identity, does anyone know what that is? Anyone maybe not? Yes. Remember maybe in numbers, 1 is the multiplicative inverse. So what that means is if you take any number and you multiply it by 1, what is your answer? The same number, right? So 1, the number 1 is what we call the multiplicative inverse. Number 0 is the additive inverse. No, sorry, I'm saying wrong. Multiplicative identity. 0 is the additive identity. Okay, I'm going to say that again. 0, the number 0 is the additive identity because when you add 0 to any number, you're left with that same number. Okay. Now, the identity matrix is a multiplicative identity. What that means is that if you take any matrix and you multiply it by the identity matrix, you get that same matrix again. Okay, I'll show you on the next page. We'll do a little example. But basically, if I have this and I times it by 2, 1, my answer is again going to be 2, 1. Okay, back to this note. We are going to multiply both sides of our equation by the inverse of A. What am I going to get if I do that? If I multiply this matrix by its inverse, what is my answer going to be? The identity matrix, 1, 0, 0, 1. That's what we said when we wrote down. That was the definition of an inverse, right? A matrix that when you multiply it by the other matrix, the answer is the identity matrix. Okay. I'm going to show you exactly why it works. If you're confused, don't stress. Let's quickly find the inverse of this matrix. Here, this is A, all right, in our equation. So remember, for the inverse, we do the determinant first. What is 8 times -3? Negative 24. Now we must minus this product. What's 5 times -25? Sorry. 5 times -5. Okay, so we have -24 minus -25.
Negative.
Oh, 1. I thought you were saying y. I'm like, what do you mean? Yes, it's 1. Hey, so -24 minus -25. So basically -24 plus 25. So that's 1. So that's quite nice, guys. So let's just write here. Wait, let me do it on black. 1/1. You obviously don't have to write that. No, I'm just showing you 1 over determinant. Wait, okay? Yes, and now we have to do the swap and the change of sign. Okay, so we're swapping 8 and -3. So this is going to become -3. I'm going to have my 8 over here. And these two, we're going to change the sign. So 5 now needs to become -5. And the -5 there needs to become 5.
I think I missed this one.
This is on my thing.
I know.
And now we're just going to write the rest of what we had originally. Oh, but we did it wrong in the homework, so maybe we did misunderstand.
Yeah.
When did I get that? I don't think you guys was chatting physics, but
Yeah.
again.
I know we always chat about that.
Okay, so what's happening here, guys? This is the inverse. And this is A. I'm trying to have such a
Yeah, little bracket thing, so yeah, same.
equals. Now, guys, we know that in an equation, whatever you do on the one side, you have to do on the other side as well, right? So I am also going to put the inverse of A here, and then I'm going to multiply that by the second graph matrix that we had, which was B. Okay. And I'll explain to you now why we're writing the inverse first and then the B matrix. So what was this again? I'm going to write it exactly as I did here. Again, guys, one you don't have to write, but because it's an example, let's do it properly. Okay, so that you know exactly what's going on. So this was 1 over 1. And then we have our bracket. -3, -5, and was it 5 and 8?
Yeah.
Yes. And this is being multiplied by the matrix that was there originally, which was the matrix of those constant terms. So this is again the inverse of A. And guys, the reason why you have to put your inverse matrix first is because if you swap the order, you wouldn't be able to multiply those two matrices. What matrix is this? A 2 by 2. Right? What matrix is this? 2 by 1. If you put this matrix first, your inner numbers wouldn't be the same. Okay, so you wouldn't be able to multiply those two together. So it's very important that on both sides, on the other side it doesn't really matter, but for the sake of uniformity, all right, let's put the inverse matrix first on both sides. It's this. This is the constant terms of the two equations. Now, guys, what am I going to get? I've said this already, but I'm going to say it again. When you multiply in a matrix and its inverse, you get the identity matrix. So this is going to give you 1, 0, 0, 1. That whole thing. That whole product. You don't even have to do it, guys. Oh,
I like computing. It's very entertaining.
okay, what else is left?
See, man,
X,
we
Y.
we always want to. I mean, I still am. No, I'm not. It's fine.
Okay, so I'm just gonna write under here. This is the inverse of A multiplied by A. Like I said, you don't have to do that calculation, right? We are multiplying both sides by the inverse because we know, or we will know, or we are starting to remember that a matrix multiplied by its inverse gives you the identity. Okay, so like I said, you don't have to do this calculation. On the other side, guys, to get the actual answer, you are going to have to do this calculation. All right. So now we're going to have to do matrix multiplication. So Luckily, the number that we would have to multiply into this matrix is just 1. Okay, so we don't actually have to do it step by step. But say you had like a half there, you would first have to multiply a half into this matrix before you can do the matrix multiplication. All right, let's do this together. We're going to do row by column. All right, so for the first value in this matrix, we're going to do row 1 times column 1. What's negative 3 times negative 1? 3. Plus negative 5 times 1, which is negative 5. What's 3 plus negative 5? Negative 2. And that is what I get when I do first row times first column. Now we're going to do second row times first column. What is 5 times negative 1? Negative 5. Plus 8 times 1. 8. Negative 5 plus 8 is 3. Now what we do is the 2 by 3. It was, these ones will always be 2 by 2. And you get the other, it will always be square matrix. Thank you.
The fact that A makes one. Another one.
It can be,
And if it was
yeah.
a 2 by 2 times a 2 by 2, you just do.
So for this last one, it will always be a 2 by 2 times a 2 by 1 because these are the answers from your, and you don't have 4 answers from 2 equations. Okay,
We have a reproof.
next year. Actually, only in the first one. Okay, guys, so now this is what we're left with. What did I just say about the identity matrix? It is a multiplicative identity, right? Meaning that when you multiply anything, so let's say this matrix, by the identity matrix, the answer is just going to be this matrix again. You're going to write it on the side. Yeah. Nice. So we say the identity matrix. The identity matrix is the multiplicative identity. And what that means is, and we can also just do it quickly to just double check. If you multiply these two together, let's see, 1 times x is x, and 0 times y is 0. So what does that leave me with? What's x plus 0? Just x, hey? So if I actually multiply these two matrices together, I'm going to get x. And what about second row first column? What's 0 times x? 0. And 1 times y is y. So that leaves me with y. So that is leaving us with this, that xy is negative 2, 3. So x is negative 2. And y is 3. Yes, but in an AP exam, I will have to specify which must be the different way. But if in terms of like mark allocations, you don't have to write both of these lines. You have to write this line. Okay, I have to see that you know that when you multiply an inverse and the matrix, you get the identity matrix. Okay. You have to show this line. Yes, I will just now. The second line you don't have to show. The second line you can just go straight. Well, I mean, whatever line this is. This line you don't have to show. You can just go straight to the answers. So let's just quickly look at mark allocations again. We said 1 mark for setting up your matrix equation. Then you'll get 2 marks for this line. So it will be 1 mark for getting the inverse and 1 mark for multiplying both sides by the inverse. Okay, so 1 mark for actually calculating that inverse and then a mark for using it in your equation. A mark for getting the identity matrix level, actually showing that. And then probably one mark, maybe two, I'm actually not sure now, for your answers. Okay, it's the same concept, just reading it all. So I think only one mark for that. So how many marks is this? 1, 2, 3, 4, 5. Yeah, I think it is a 6 mark question. Yes.
Like what's the concept of the bar? I guess, it seems, but what, not find the inverse of the rectangle. Then you can't have the median.
Yeah, it was square.
So like, what?
Okay, guys, I'm going to ask you to do 2 of these on your own. For whenever, we actually are not sure now of when we get back to this. No, Friday you're doing your test.
Oh.
And on Monday we're gonna do 4. I'll just let Miss Jansen know that I'm gonna carry on with 4 with you guys. Oh, because then the Monday is a public holiday. No, surely guys, I can't give you a right to.
I'm right, man.
Oh my god, it's so important. Yes, I know.
It is right.
Christina. Christina, yes. Yes. You with kind of stuff. So, and also in this part, and it's either like the Alps or like beautiful like or something. Like so yesterday I was trying to call everything was the same to me. Anyway, because like
I know.
so and then she went and it was pretty much like okay. And now it's just smoking in the bedroom. I don't know now, what do you know about this? Like, I don't smoke it. No, you don't give me smoke a lot. If you like fun. Okay, guys, I am giving you just a few more because it's 2 weeks. So
I'm thinking that's another one.
I need to write. What is going on there? Wow. So don't give us that one. No, I'm just reading through these questions and I'm like, with the chair, I was walking to school every day and I was like smoking in the I found it so funny. Okay, guys, that is your homework. Next week, not next Friday. Okay, the reason for that is on Monday we're gonna have to do 4 so that you are already at your test, which is on Friday next week, right? And then the Monday after that is a public holiday, and on the Tuesday, and then we'll only do 18 again that Friday, which is the 12th of August. But which seems very far away, I mean, it is, given the fact that today is the 29th of July. Yeah, I know, time goes by very quickly. Possible, do it? But,
Let me homework Wednesday, not Monday.
Yes, although I don't have that, office over here. Oh, but she is here on Monday, okay. Okay, it's fine, she can walk it with you on Monday. So guys, Miss Johnson gave you guys homework for Wednesday, next week you'll have to do it for Monday, okay? Because you're gonna have 4 on Monday. Here is that, so we have. That's it. And guys, in terms of AP, let's go. So let's go.
No, it's the. What's the rank?